All right, and so for each of these, as you're doing it, when it says expand, first of all, notice the wording that's being used. That's going to be a big deal here in coming days too. When it says expand, what it's really saying here is use the distributive property. And so I'm going to multiply, in this first example, the 5 into all 3 of those terms. Multiply each of those 3 by 5, and then that's really just going to be your final answer from there. And then, of course, repeat with the second one as well. So for doing this one, if I multiply the 5 into every term, 5 times x to the 6 gives me 5x to the 6. The minus, of course, stays a minus. And then I do 5 times 3x. So 5 times 3 is 15. And there's nothing changing the x, so it stays an x. And then the plus stays a plus. And then I do the 5 times the 8. That gives me 40. That's it. That's our final answer, because there's nothing that can be combined there. There are no like terms that I can add. Now, repeat the process with the second. In this case, I'm multiplying this 6 by all 3 terms. So 6 times 3 is 18. So that's 18x to the 7th. Plus 6 times 5 is 30. So 30x squared. Minus, and then 6 times 10 gives me 60. Now both of these are examples of problems where we expanded our work by using distributive property. Today, one of the things that we're going to be getting into a little bit more is doing the same thing backwards. So today we're factoring, which really is just the same thing backwards. So please, write down that first problem, and I'm going to lead you through how that works. So in order to do that first one, if I'm going to do distributive property backwards, that means that my final answer, when I'm done with this, should have a set of parentheses with some number written out front of it that I've divided out of every term. And so what can I divide all 3 of these terms by?
5.
Absolutely. So that means the first thing I do is I write the 5 out there, because that's telling me what I'm going to be dividing by every term. So if I take 5x cubed and divide it by 5, I am left with just x cubed. You could say it's 1x cubed, but it's cleaner to write x cubed. Now the minus is still a minus in there. Now do the same thing with the 15x. So what's 15x divided by 5?
3x.
3x.
Oh, I don't know.
And then the plus stays a plus. And then I do 35 divided by 5, which is? 7. And now a little side note here. There will be problems at times where you might look at it and say, I factored something out, but it says I'm wrong. Because maybe you didn't pull out the biggest number. Because what if I could pull 10 out of every term in a problem like this, and I only pull out a 5? How would I know? If you look at all of the terms in your answers inside of the parentheses, check to make sure there's nothing you can divide all 3 of those by. In this case, 1, 3, and 7, yeah, there's nothing I can divide them all by, definitely. But that's what tells me that I pulled out the biggest number. If I could, for instance, divide all of them by 2, it'd tell me I actually didn't pull out the biggest number, and I need to keep going with it to do that. Okay? You won't have to deal with that much today, but I do want you aware of it for when it does come up. All right, so now please repeat the process. Factor that second problem out down there. Remember, write down the original as well as your answer. So the big question in answering this and factoring it is, what number is going to go in front of those parentheses? In other words, what can I divide 18, 15, and 24 all by? So what can I divide them all by? 3. So that tells me that I'm going to have a 3 out front of my parentheses. So now I go ahead and start dividing through by that 3. So 18 divided by 3 is 6. The x to the 5th is unchanged here. Plus stays a plus. So 15 divided by 3 is 5, and the x is unchanged here. And then the minus stays a minus. And 24 divided by 3 gives me 8. And so then that's my final answer. And if you're ever doing one of these and you're not sure if you actually did it correctly, you could, you don't have to, but you could actually multiply the 3 back in and use distributive property. And if you do, you should end up with exactly what you started with. Because remember, we're doing distributive property in reverse. That's all factoring is.
So you can just do it.
All right, now continue to practice some of these ideas. I want you to expand a few more of them, just like we did with the very first two problems we did. Now this one's again following up on the same kind of expanding process where I'm going to use distributive property. So I'm going to multiply this x squared into all three of those terms. Now let's start with the x squared times the 7x to the fifth, because if you can do that, you can probably do all the others as well. Notice that there's no number with the x squared, like no whole number sitting out front of it. That means that the 7 is just going to stay a 7. Now I need to do x squared times x to the fifth. Now that gives us x to the power of 7, which we can know a couple different ways. One way is you can remember when I multiply the x's, I add the exponents. Or if you don't remember that, you can actually think back to what does that really mean. It means I'm doing x squared, which is x times x, times x to the fifth. So notice that's a grand total of 7 x's all multiplied together. All right, plus. Now I'm going to do the x squared times x. That's going to give me x to the power of 3. And then when I do x squared times the 4, that gives me 4x squared. So that's what you should be getting there for your first answer. If you had any trouble with that, go and apply it to the second problem. All right, and now for the second one, I'm going to do the x to the fifth times 8x to the fourth. Again, there's no whole number with the x to the fifth, so it stays an 8. Then x to the fifth times x to the fourth gives me x to the ninth. Because when I multiply the x's, I add their exponents. All right, next up. It's minus, and I multiply the x to the fifth by 5x cubed. So the 5 stays a 5. And then again, I add the exponents. So 5 plus 3 gives me the 8. And then I do the x to the fifth times the 2. Well, there is no x in the 2, so I can go ahead and just multiply those and get 2x to the power of 5. And that one is now done. Now I'd like you to apply what we just did with expanding with the x's to factoring with the x's. And like we did last time, I'm going to lead you through that very first one. So write down that first problem. So for that first one, we need to figure out what we can divide every term by. And this one can sometimes be a little bit trickier at first. Because notice there's no number I can divide out of every one of them. I mean, I could pull the 5 out of both of those, but I can't pull it out of the first term. And so the only number I could pull out is 1, but I could pull a 1 out every time. So there's no use in pulling a 1 out. But notice that every term does have some x's in it. And so I'm actually going to be able to pull some x's out. Remember in the expanding problems that you just did, look at your answers that you came up with. And in each of those, we ended up with an answer that had x's in every term because we multiplied them in. Well, notice then what I could pull out doing the same process backwards. In this first problem, I could actually pull x cubed out of every term. Let's take a look and see why that is. So the first thing is that since I know I'm pulling out x cubed, I'm going to write the x cubed out front of my parentheses first because I'm factoring. So I know I'm going to end up with something out front of the parentheses. All right. And now I need to do x to the ninth divided by x cubed. Well, it might be easier at this point to think about x cubed times what is x to the ninth. Remember when we multiply them, I add the exponents. So if I were trying to do x cubed times x to the power of something that was going to equal x to the ninth, it's basically saying 3 plus what is 9? It's 6.
Wait, how did we get the x3 actually in the beginning?
And so you can see that the rule you're using when dividing, so like when I'm trying to say what's x to the ninth divided by x cubed, I'm subtracting the exponents. So I did 9 minus 3 to see that it was x to the 6. All right, now let's continue that process and finish this out, so I don't need this anymore. All right, so the minus is still a minus there. Now, I'm just pulling out an x cubed, so the 5 in the middle term is not affected, so it's still a 5. But I have x to the fourth, and I'm taking out x to the third. In other words, I'm taking out 3 of those 4 x's, which leaves me with just 1 of those x's. So it's 5x. It's 5x to the 1, but I don't write x to the 1 power because that's just x. All right, then I write the plus in because whatever the plus or minus is between them, it stays what it was. And then 10x cubed divided by x cubed, I'm pulling out all of the x's. So I'm only left with just the number, so I'm just left with the 10. And then that's our final answer. Which also reminds us about how do we know to pull out the x cubed here? Because notice in the last term, that was all of the x's. So basically I looked through my terms and I said, okay, this one has the least amount of x's. And so that was how many I could pull out of all of them. Please repeat the process with the second one.
So how?
For this one now, we need to start by saying how many x's I can pull out of every term. Because I can't pull any numbers out, 20, 11, and 25. The only thing that goes into those is 1, so I can't do anything there. But I do see x's in every term. And notice I can actually pull 6 of them out of every term. Because like I can pull x to the 6th out of x to the 8th, but I cannot pull 8 out of the 6 here. So that's why I know to pull out x to the 6th. So let's start by writing that out front. And then it's just a matter of x to the 6th times what gives us each term. So for the 20x to the 8th, the 20 is unaffected because we're not pulling out any numbers. The x to the 8th, I have 8 x's, I'm pulling out 6 of them, so I'm left with 2. So I'm left with x squared.
2? 20?
All right, next up, the 11 is unchanged. And then if I take x to the 7th divided by x to the 6th, that's x to the 1, which I just write as x because x to the 1 equals x. And then minus, the 25 is unchanged. And I'm pulling all of the x to the 6's out. So there's no more x's left. So that is now completed. Next up, we're again going back to expanding. So please expand both of these. All right, so on the first one, we're still using distributive property because it says to expand. So I'm going to multiply the 4x cubed by x to the 7th first. So notice the 4 multiplies by any whole numbers. There is no whole number in this one, so that 4 is going to stay a 4. And then I do x cubed times x to the 7th. That is going to give me x to the 10th. Because remember, when we multiply, we add the exponents. All right, next up, I'm going to be multiplying those two. So the minus stays a minus. I do the 4 times the 9, because the whole numbers multiply. That gives me 36. And then the x cubed times x. That's going to give me x to the 4th. Because, again, remember that x is x to the 1. So I'm basically doing x to the power of 3 plus 1. So I'm doing the x to the 3 times x to the 1. So x to the 4th. All right, and then finally, we multiply by that 2. So the minus in front of it stays a minus. The 4 multiplies by the 2 to get an 8. The x cubed, well, there's no x in that term to change it, so it stays an x cubed. Now repeat that process with the second one if you haven't yet finished it. All right, now for the second one, we're going to repeat that same process. I'm going to multiply the first term by the number outside. So I do the 10 times the 4, which gives me 40. And then x to the 7th times x to the 5th gives me x to the 12th. Because remember, when I multiply the x's, I add the exponents. All right, next up, I got a plus. And now I'm going to do 10 times 13. 10 times 13 should be mental math. Because anytime you multiply something by 10, you're adding a 0 to the end of it. So 13 with a 0 on the end, 130. That's 10 times 13. And then there are x's still, so I do x to the 7th times x cubed. That means x to the power of 7 plus 3. So x to the 10th. All right, and then I need to multiply by that last term by the 1, so it's going to be plus. Well, 1 times anything is just itself, so that's got to be 10x to the 7th still.
faster.
Now, as you might expect, each time we've done an expanding problem, we've then factored that sort of thing out. We're going to do the same thing here, but notice what that means in this case. In previous problems, we either factored out a number or x's. In this case, notice I had you distribute in both a number and an x. That's what you're going to be doing here in a moment. Is you're going to be looking at each of the numbers and seeing what number can you pull out of each. And then you're going to be looking at the x's and seeing what x can you pull out of each.
Are we doing
So it's
both?
basically doing the same thing, just both of them at once.
Are we doing both?
So here's your problems. Write down that first one and we'll walk through how to approach it. All right, now again it says factor, so we know we're doing distributive property backwards. I'm going to end up introducing parentheses. That's what factor is telling us to do. So I have to look and see what can I divide every term by. And as we talked about, you can expect there to be both numbers and x's to pull out here. So looking first at the numbers. So that means the 3, the 12, and the 30. What can I divide all of those by? 3. So the first thing I'm going to write down is 3, but I'm not going to start my parentheses yet because I also got to look at the x's this time. How many x's can I pull out of every term?
x3.
Yep. It's going to be x to the power of 3 because that's the smallest number of x's that I have in there. So I can pull out 3x to the third, or 3x cubed. All right, now I go ahead and do that. So first I do the 3 divided by 3. Well, that gives me just 1. So it's like I'm going to have 1x to the something, but I don't need to write that 1 in. So I'm just going to go straight to the x. So I do x to the 6 divided by x cubed. Well, what's 6 minus 3? 3. So that gives me x to the third. All right, now I do the plus there.
Wait, I have a question. Why? How?
All right, next step. We go to the 12x to the fourth. What's 12 divided by 3?
4.
4. So that tells me that I have to have a 4 here. And then I have x to the fourth. And I'm taking x to the third out of that, which leaves me how many x's? 1. So rather than writing x to the 1, I'm just going to write x there.
Would you be wrong if you just write that?
It's not necessarily wrong to write x to the 1. It's just, why do we want to have a bunch more numbers thrown in there than we have to, right? There's already enough stuff going on in this. And then it's minus. And now I do the 30 divided by 3. That's 10. And then x cubed divided by x cubed, well, that's just 1. It cancels itself out. So then this is my final answer. All right, now on to the second. The first thing I'm doing in this second problem is I want to take a look and see, can I factor out a whole number?
Yes, you can.
And so, more specifically, that's looking at the 4, the 28, and the 8. And what can I divide them all by?
4. 2.
You notice there's actually 2 numbers I can divide them by.
4. But you said the biggest.
And so, we can factor out both 2 and 4, but we do always want to pull out the biggest one. Now, if you factored out a 2, what you're going to notice is that at the end, the stuff inside the parentheses would still be divisible by another 2. So, I don't want to do the 2, I just want to do the 4 here. So the first thing I do is I write down my 4, and then I look at my x's. And let's see, of the x terms, how many x's can I pull out of every term? 2 of them.
So.
Yep. So since I can pull out 2 x's out of every term, it's going to be 4x squared outside. Now we divide everything inside by that. So the 4 divided by 4 cancels out. X to the 9th divided by x squared gives me x to the 7th. Now the minus. 28 divided by 4 is 7. X cubed divided by x squared is x. Plus stays the same. 8 divided by 4 is 2. X squared divided by x squared cancels out. So this is our final answer. Now if you hadn't pulled out the biggest term, let me just show you, like, what if you just pulled out the 2x squared instead?
Wait. For the 28.
So if we had just pulled out that 2x squared, we'd have 2x to the 7th minus 14x plus 4. And notice that in here, if I look back at the 2, the 14, and the 4, I can still divide them by 2. So it's a red flag if there's still something you can pull out of every term.